In this lesson, we're going to talk about the investment horizon and interest rate risk. It's a really key video which leads us up to the duration discussions that we're going to have in the next recording. Now, if this is your first time on the Let Me Explain YouTube channel, then a very warm welcome. I hope you find this video useful and insightful. If you do, please subscribe to the channel, but also please consider joining the channel as a member, in which case you'll get access to the full range of videos available. And do visit the companion website. You'll find the link to that website in the description of the channel on its homepage to see what videos are already on the channel and what is planned for the upcoming future. Okay, let's get cracking with the topic, investment horizon and interest rate risk. I'm going to talk about this via a rather extreme example which I made up because I think the curriculum doesn't do justice to this topic. Well, it doesn't explain it as I would like to do so. So my example is going to be very simple, but as I said, extreme. So we're going to consider a 3-year bond that pays an annual coupon, and the coupon rate is going to be very high, 64%. I've made this intentionally so high because I wanted to get a specific result. It's an annual coupon. Irrespective of this number being very extreme and very far from what you would normally see in exam-style question, I think it will get the point across. And what is more, the yield to maturity on this bond is going to be 60%, so very close to the coupon rate, nevertheless slightly below. So from that relationship of the coupon rate and the YTM, the yield to maturity, you can probably already see and guess that we're going to have a bond which currently trades at a premium to its par value. So let's quickly compute the purchase price for this bond. And we're going to utilize the time value of money worksheet to do so. So the inputs will be as follows. N will be 3. The PMT, that's our coupon, is going to be 60, well, not 4%, it's just 64. And the YTM is going to basically be the I over Y parameter. We're going to set that at 60. So let's clear the time value of money worksheet first, as we always should. And now with the inputs, 3 for N, right, first the input, then tell the calculator what it is. So 3 followed by N, 64 followed by PMT, 60 followed by I over Y. Of course, I'm missing one more thing. FV is going to be 100, so 100 for FV. And now get the calculator to compute the I over, sorry, not the I over Y. Get the calculator to compute the PV, the price, CPT PV. Okay, out pops 105.04. Good, that's going to be our starting point. And now I'm going to assume, just like I did in the previous video, that the investor will sell this bond, or investor sells the bond prior to its maturity date. They don't hold it until maturity, and they'll sell it after 2 years of holding. Okay, and we will explore actually 3 different scenarios. The first one is, let's call it scenario A. The assumption in this one is going to be that interest rates or yields stay constant, remain constant, and stay at 60%. So we'll still have yields to maturity of 60% in the market, basically. And if you watched the previous video, or if you've done some prior learning or studies on this topic, you will know what happens if yields don't change. We stay on the constant yield price trajectory, and we sell the bond for its carrying value, and there should be no gain or capital gain or loss. And the YTM staying the same will mean that we have a horizon yield that should equal to the original YTM 60%. Let's check if that's what happens. So the selling price of the bond is going to be once again computed using time value of money, TVM. The only thing I'm going to substitute or replace is the fact that we now, after 2 years' time, only have 1 year left until maturity. So I'm going to make my N input equal to 1, because after 2 years there will be only 1 year left of the bond's life. Overwrite the N with the 1 and get the calculator to compute PV again. CPT PV, right. 102.5 is the selling price. Right now, because we sell at a price that comes from having the same yield, 60% is still the I over Y parameter that's stored in your calculator. We can definitely say that there is no capital gain or loss in that sale. We talked about it in the previous video when there is a capital gain or loss. Let's think about a timeline. Time 0 when we purchased, end of year 1, end of year 2 when we actually sold, and we didn't wait long enough to see what happens at the end of year 3. So this is the selling price over here, 102.5. We initially paid a price of 105.04 to get into this investment. Okay, and in the meantime it generated some coupons. A 64 coupon, recall this bond was paying coupon at 64% of par, so 64 here and 64 here. Now I've made this example extreme because I wanted to get something that we can learn from without doing too many calculations, too many elaborate calculations. Because the thing about this example is, if you sell at the end of year 2, this first coupon will only have 1 year of reinvestment period. Okay. Now, given the fact that interest rates throughout stay at 60%, right, this coupon of 64 will grow by a factor of 1.6, or it will change by a factor of 1.6 if it is reinvested until the end of year 2. So let's do this on the calculator. 64 times 1.6 gives a pretty impressive 102.4. Now, let's just see how much growth there is from the reinvestment, how much gain there is from the investment. 102.4 minus the original 64, that actually gives 38.4 from the reinvestment of the coupon from year 1. Good. What we care about is the horizon yield. Typically, this is what we did in the previous video. So I'm now going to simply sum up or sum all these items. We've got 102.5 at the top. That's the selling price. The year 2 coupon, which doesn't have any time to be reinvested, and 102.4 to give us a total over here, down here, equal to 268.9. Just like we did in the previous video, we can turn this into a horizon yield, the rate of return experienced by the investor, which includes the selling price and also the reinvestment of coupons. So 268.9 goes to the numerator of the fraction. In the denominator we are going to have the price at which the acquisition, or at which the purchase was made, 105.04, and we need to take the square root of this because it occurred over a 2-year period. So raise this to the power of 1 over 2. Maybe let me get rid of this little arrow here, as it is obstructing the fact that we've got a power of 1 over 2 or 0.5, and we need to deduct 1. So I've got the 268.9 on my calculator. I'm going to divide by 105.04 equals, now either raise this to the power of 0.5 or simply press the square root button, x under the root symbol, good, -1, and as you can see we get very close, really very close to 60%, which is our original YTM. And this simply proves the point that we were making in the previous video. Even if you sell the bond prematurely ahead of the maturity date, providing interest rates have not changed, you'll still get, or you'll still realize a yield, a horizon yield, and realize an investment rate that is equal to your original YTM under the condition that the bond is sold at the same yield as when the purchase was made. However, the more interesting, let's say, discussion comes, or analysis comes, if we entertain a different scenario. I'm going to call it scenario B, in which I will assume that immediately after the purchase of this bond, after bond purchase, and definitely before the first coupon is received, interest rates in the market go from that original 60%, the YTM on the bond, up by just 100 basis points to 61%. 100 basis points is basically 1 percentage point. If that were the case, we need to compute a completely fresh selling price. So, what would that be? Well, in my time value of money worksheet, I still have, stored those original numbers from the previous computation that we did up here, where we substituted the N for 1, and we had a YTM of 60, a yield of 60. So, I could risk it and try to just overwrite the one parameter, but I don't advise it. In the exam you will not necessarily remember what you have stored, etc. Just clear the time value of money worksheet and do things again. Remember, we're thinking about a situation where the investor sells the bond after 2 years. That's common for all the scenarios. It's just a question what's happened to interest rates, So we will still have an N equal to 1. This time our I over Y, N equal to 1, because there will now be 1 year only left to maturity. Our I over Y will be this increased 61. The FV will still be 100. The PMT will still be 64, that very high coupon. So, okay, I can't remember if I cleared my time value of money worksheet or not, so let's do it again. Second FV, and now 1 for N, 61 for I over Y, 100 for my FV input, and 64 for the PMT, and I want to compute PV, CPT PV. Okay, I'm looking at an answer of 101.86. Now that is a result, that is a selling price which is definitely lower than the price I would have had if I sold with yields staying at 60%. That's to be expected. Bond prices and yields move in opposite directions. So yields up, bond price down, relative to what it would be if it were not for that drop. So let's use this information to chart things on a fresh timeline. Time 0, end of year 1, end of year 2, and we've got this selling price 101.86 over here. Also, let's recall that this bond was initially costing us 105.04, and it doesn't, there is no impact on this of yields subsequently changing. That purchase was made when the yields were 10%. However, this time around, the year 1 coupon, by virtue of being invested or reinvested at a slightly higher interest rate, one of 61%, will have had an opportunity to grow to a higher amount. So let's see what that is. 64 times 1.61, 64 times 1.61 gives 103.04. Good. Let's see what the total gives over here. This, and this. 101.86, the selling price, plus 64, the coupon received at the end of year 2, plus 103.04, which is the coupon from year 1, which has had an opportunity to grow due to reinvestment, gives us an end of year 3 total of 268.9. Now, let's compute the horizon yield. 268.9 divided by the initial purchase price of 105.04 raised to the power of 1 over 2 minus 1. This should be ringing some bells, to be honest, if you paid attention and you did some computations along with me. If you didn't, minus 1, look, it's once again equal to 60%, the original YTM. How come? Well, the purchase price was the same, and so is this total. 268.9 is the same total as we had in the previous example where there was no change in yield. How is that possible? Well, remember what happens. You should remember from the previous video, when yields or interest rates change. There are two things happening. On the one hand, the price for which you sell the bond changes, but there's also a change to how much gain you make from the reinvestment of the coupons. And more times than not, one of those effects is going to be stronger than the other, but not in this case. The two effects will exactly offset one another, and I had to really play around with the numbers. That's why I made them so extreme, to make that possible in a very sort of short-spaced example of just 2-year investment horizon. So let's check what happens here. First of all, we make, or the investor makes, a bit of a capital loss because they sell the bond for a price that is lower than the carrying value. And remember from the previous video, those of you who had an opportunity to watch it, that carrying value is a price that we derived from that constant yield price trajectory. How much is that capital loss? Well, what you have to do is you compare this amount, 101.86 for which the bond was in fact sold, with the price for which the bond would sell if there had been no change to the yield, if the yield had stayed at 60, and that was 102.5. 102.5. Let's compute that difference. 101.86 minus 102.5. Okay, that's a negative difference because it is, after all, a capital loss of 0.64. However, look at this. The amount we get from the first coupon is 103.04. And if we compare it to the size of the coupon, which was just 64, that means a 39.04 sort of gain from the reinvestment of that year 1 coupon. Well, how does that compare to how much gain we had from the reinvestment of the coupon under the previous setup, where yield stayed at 60 and the coupon only grew at 60% for 1 year? Over there we calculated 38.4 from the reinvestment of the coupon. So 39.04, which we get over here, minus 38.4, which was the case before, gives an extra gain of 0.64, this time positive. And look, this number and this number are the same except for the sign. The capital loss is exactly offset by the additional gain that we get from reinvesting the coupon at a higher rate, which is quite a special case, to be honest. Now let's check one more thing. And actually your curriculum explains this, but I feel they don't go into as much details as this. Now, you may not wish to have so much detail, but I think it helps to understand what duration is about, which we're going to get into in just a moment. Let's entertain one more scenario here. Scenario C, let's call it. And under this scenario, what we will assume is that immediately, again, after the purchase of the bond, it doesn't have to be immediately after. It's enough that it happens before the first coupon is received. That's what matters. Interest rates go down from the initial 60, which was our YTM, to a level of, well, let's do it by 100 basis points, to a fresh level of 59%. Okay. What would happen now? Our selling price would again change. Now, I'm not going to retype everything on my TVM. I'm just going to do one substitution. I'm going to make I over Y equal to 59 because I trust everything is there. I did it not so long ago. So 59 for I over Y and CPTPV, compute present value. Okay, a fresh price of 103.14. Good. Let's put things on the timeline. Again, time 0, end of year 1, end of year 2. So this is the selling price we receive over here. It goes nicely in there. What else? We have our standard purchase price that was paid at time 0. Let's just recall what it is. It was 105.04 from the previous scenario. That stays uniform throughout all the scenarios. So this is a 4. Over here we get a coupon of 64. Over here we got a coupon of 64. But this one has an opportunity to get reinvested and accrue some value. This time, however, at a rate of 59% only, so times 1.59 to get that future value after one additional year. 64 times 1.59, okay, 101.76. As we did before, I'm just going to count and sum all these elements, positive elements of value that make up what we sort of finish the second year with. We have our selling price 103.14, we get the second year coupon 64, and we have that 101.76, the value of the reinvested coupon after 1 year. Look, 268.9. It's the same sum that we saw before, and we've already seen it twice, over here and for the first time over here. And because whatever we have, whatever we end up with at the end of year 2, goes into the numerator of our horizon yield formula, and into the denominator we pack the constant purchase price, we take the square root, deduct 1, you know, we will get the same horizon yield as before. Horizon yield, in this case, is still going to be that same 60%, which is equal to the original YTM, yield to maturity. Okay, let's check what happened here. Well, we managed to sell the bond for more this time, so we generated a capital gain. Remember, a capital gain or a capital gain or loss is computed as the price for which you sold the security, the bond, 103.14, versus or minus what the price would have been had the bond been sold under the constant yield from the original constant yield, which was 60%. And if that had been the case, we would have sold it for 102.5. So minus 102.5 gives, let's check this, 103.14 minus 102.5. Okay, well, we generated a bit of a gain over here. However, the reinvestment of that first year coupon, how much did that give? 101.76, that's the value after one additional year, minus the original coupon size 64, that gives 37.76 from reinvestment of coupon number 1. And if you compare that to how much was generated under the no yield change or the constant yield scenario, where yield stayed at 60%, that was 38.4. So 37.76, which we have here, minus 38.4 gives a loss, obviously relative to the constant yield scenario. And once again, the two offset one another, which is why we end up still having the same value at the end of year 2, 268.9. No wonder. Right. As you can see, hopefully, from these very elaborate examples, it took a long time, but I hope you're now convinced that regardless of what happens to interest rates, we end up having the same horizon yield. So the horizon yield is the same, stays constant, irrespective of interest rates, either going up or down. It's as if our result is kind of immune or hedged against interest rate fluctuations, which is quite interesting. And you may be, thinking, or you should be thinking, why is this the case? Well, it's because the 2-year investment horizon, which I specifically chose in this scenario, I told you the investor sells the bond after 2 years, so they had a 2-year investment horizon. Well, I chose it because for this bond, and this bond only with its parameters, I had to make the parameters quite extreme for this to work. 2 years, the investment horizon is equal to the bond's Macaulay duration, which is something you'll be learning about a lot more in subsequent videos. But this is only the duration of this bond. It's not a universal number for, all bonds. Macaulay duration, so this thing is the holding period, or the investment horizon if you want, which balances the two elements of interest rate risk: the coupon reinvestment risk, the fact that when interest rates change, the coupon gets reinvested at a higher or lower rate, and price risk, the fact that when yields change or interest rates change, your bond stops. Your bond price is no longer on that constant yield price trajectory, so it moves away from its carrying value, and you start selling the bond basically with some element of capital gain or loss. When we say balances, what we mean here is that the two offset one another. Okay. Why is it called Macaulay duration? This is named after an economist, Canadian, Frederick Macaulay, who came up with this measure. And let's just say it may be important for a theoretical question. It only works for a one-time, so a single moment, instantaneous simultaneous parallel shift in the yield curve, meaning all interest rates move at the same time on different points of the yield curve up, for example, by 50 basis points, as we had over here. Now, so look, you won't probably get questions on this, but I thought it would be good to do something numerical with you to get you to appreciate that there is a number, a holding period, where our bond and the investor is immune to what happens to interest rates. When we did the example in the previous video, that wasn't the case. The investor's horizon yield did change because the horizon was not equal to Macaulay duration. How did I come up with the number 2 here? It wasn't by accident. In the next video, we're actually going to compute it. So we will be computing Macaulay duration, both using sort of longhand paper and the calculator as well, to make things, I guess, simpler. But you need to understand the logic, so we'll be doing the full computation anyway. Now, a few important comments. Pay attention, please. This is extremely important from an exam perspective. I'm going to start off with the case if the investment horizon that the investor chooses is exactly equal to Macaulay duration. In our case, that was 2 years. And by the way, Macaulay duration in your textbooks and in various sort of spreadsheets, etc., is often denoted as Mac DUR. If this is the case, then the investor's price risk is exactly balanced against reinvestment risk. And as I said, neither of these risks dominate. They perfectly sort of offset one another and balance one another. However, the tricky situation, this is something you need to appreciate, is that if the investor chooses a horizon for their investing which is longer than the bond's Macaulay duration, so in our case that would mean you hold the bond for longer than 2 years, then potentially what will happen is the reinvestment risk, the risk associated with reinvesting the coupon for a longer period of time will prevail over the effect to the price of the bond, the price risk. So you could say that this is the dominant risk. And I'm going to explain this in a moment, don't worry. This becomes our dominant risk out of the two. When is this a problem? Well, if interest rates go down, if interest rates fall, you will make a relative loss on the reinvestment of coupons. So you will not make as much from the reinvestment of the coupons as you would had there not been that change in yield, downward change in yield. And that loss on the reinvestment of the coupon will unfortunately be bigger than the gain or the capital gain on the bond price. So let me change this to capital gain from the bond price going up. Because bond prices do go up when interest rates fall, don't they? On the other hand, if the chosen investment horizon, so the investment horizon which the bond investor chooses, is less than Macaulay duration, which once again in our example was 2 years, you'll have the reverse situation. The reinvestment risk will stop being the dominant of the two, and price risk will prevail. So this will now dominate. This will be the dominant risk. And okay, what would be problematic in this case is if interest rates go up, then of course you'll have a capital loss, because the bond price would drop relative to where it would be had it not been for the interest rate increase. So bond price drops. And okay, normally we would say, okay, but this gets to some extent offset by the fact that we are reinvesting the coupons at a higher rate. Well, if your investment horizon is not long enough, you're not giving yourself enough time for that reinvestment effect at the higher interest rate to really offset the price drop, right? So capital loss is bigger than the gain from reinvesting the coupons at the higher rate. That's what it's all about. Which effect will be stronger? And it's a question of time. So, think about this way. This may be difficult to remember for many of you to memorize, but if you have a longer investment horizon, then, you're giving yourself more time for the reinvestment effect to work. However, that will prove problematic in case interest rates drop. However, on the other hand, it will be a good thing if interest rates go up, in the sense of having a longer period in which interest rates are doing more of the work in terms of the reinvestment. However, if your investment horizon is not long enough, then shorter than the Macaulay duration, then this will not suffice. When your investment horizon is exactly equal to Macaulay duration, the two are perfectly balanced. Now, one more thing that you need to know, the so-called duration gap. It comes at the end, but it's nevertheless very, very important. This is the difference between Macaulay duration for an investment and the investment horizon. So, if this gap is above zero, meaning Macaulay duration is higher than the investment horizon, the dominant risk is going to be price risk. And you'll be, as an investor, in trouble. That's the investor in trouble if interest rates go up, because then the drop in the bond price, the capital loss, will be bigger than the effect of reinvesting at a higher rate. Why? Because you don't have enough investment horizon. Your investment horizon is too short for the reinvestment gains to really offset the drop in bond price. On the other hand, if this is negative, then the dominant risk becomes the reinvestment risk. And that means you're in trouble if interest rates drop, if they go down, because then the reinvestment of the coupon turns out to be loss-making relative to the constant yield scenario. And unfortunately, because you're reinvesting the coupons for a longer period of time, then Macaulay duration would suggest even the rise in the bond price is not enough to offset that loss.